Number 45, a heavy truck and a light truck roll down a hill. The heavy truck will have greater what? So your answer should be momentum because momentum is m times v, right? So the mass will have what did I say? The mass will have more impact on the momentum. However, acceleration, when they roll down the hill, acceleration will due to the gravity as well. So acceleration, the gravity is the same. So momentum should be right. The total mechanical energy of a system remains constant if the internal force are non-conservative, which is false because non-conservative means it's not conserved inside the closed system. That means the energy can go out and in of the system, but we learned that in a closed system, all those energy are conserved, right? The mechanical energy is conserved. So this is false. Number 49, in a ballistic pendulum experiment, a bullet of mass 0.06 kilogram is fired horizontal into a wood block of mass of 0.2. The wood block is suspended from the ceiling by a long string. Isn't that the same question that we skipped? And then we're going to skip it again. Okay. An object has a momentum of 1,000 kilogram meter per second and its mass of that. So you're looking for kinetic energy. Kinetic energy is half mv squared. We need to look for v, right? Momentum is mv. We have the momentum, which is 1,000, equal mass 50 times v, so v is 20. And this 20, you can plug it back into your v, half mv squared, half times 50 kilogram times 20 times 20 is 10,000, and your answer is B. Okay, 51. A ball of 8.5 kilogram is thrown upwards 16 meters. What is the gravitational potential energy gained by the ball? Estimate gravity is 9.81 and keep 4 sig figs. So we know potential energy is mgh. mgh, right? M 8.5, G times 9.81, and H is 16. Put them all together, 8.5 times 9.81 times 16 is 133.4. So your answer is B. Yeah, 133.4. All right, next. If the length of a steel wire increased by 0.2 centimeter on stretching it with a force of 20 Newton, then the work done stretching the wire. Well, we didn't really work too much on the work, but work is force times distance, okay? Work is force times distance. And our force is 20 Newton. Our distance is, well, change that to meter, okay? So that'll be 0.02 meter. And your answer is 0.4. What did I do? 20. Oh, 0.2 centimeter is actually crap. I can't believe I'm doing the calculation wrong. 0.002 meter. So 0.002 times 20. 0.04. Should be B. My bad. Look at what quarantine's doing to me. Can't even do math in my head anymore. Sarah goes to her apartment on the 5th floor by elevator from the ground floor. The whole journey is 18 meters if Sarah has a mass 60 and the gravity is 9.81. Potential energy, PE equal mgh. Multiply all those numbers up. 180, 18 times 60 times 9.81 is 10594. So, is this? Check it. Very good. Sasha, haven't seen Sasha for the longest time. Sasha lifts a couch 8.2 meter from the ground, and then the couch is 12 or 120, and the gravity, multiply them up. Okay. Next, what is the change in gravitational potential energy of the apple if it falls the amount shown? Estimate G to 9.81 and keep 3 sig fig. So we all know that gravitational potential energy, which is change in potential energy, is really mgh, right? Mgh initial minus mgh final. So it's really m times g, because those two never change, times delta h, the change in distance. So equal mass is 0.25 times gravity, 9.81, times 0.7 meter. Ooh, sorry about the pen. You multiply them up, 0.25 times 9.81 times 0.7 is 1.716, which is 1.72. Answer is A. 56. Calculate the amount of work must be done. Must a 60 kilogram runner do to accelerate from 0 to velocity of 2 meters per second? Let's skip that because we didn't really talk about the work, but you see, it's really change in kinetic energy, the work done, okay? So you can calculate it because 60 times, half, 60 times final velocity, which is 2 minus 0. And then if you calculate it, square. So if you calculate it, you should get 120. Okay? So 120. All right. A firewoman dropped a person onto the safety net. Right before the person hit the net, he had a velocity of 11.2 meters per second and 1,800 joule of kinetic energy. What was the mass of the person? So it is a kinetic energy problem. Kinetic energy is equal to half mv squared. mv squared, right? Kinetic energy 1800. The mass is what we're looking for, and then the velocity is 11.2 squared. You just have to do the math. All right. Next. Next question, the chipmunk dropped acorn from the top of the tree. The acorn was 0.25 kilogram, has a velocity of 4 meters per second. When it hits the ground, how much kinetic energy did it have? Kinetic energy, half mv squared. Do the work. A 3 kilogram toy car is moving at 4. Calculate the kinetic energy of this car if it were moving twice. is fast. So twice as fast. Half mv squared. Half m is still 3 kilogram. Why the pen is not working? I don't know. Half m is 3. So your velocity is 4, but twice as much will be 8. 8 squared. Okay. So now you calculate it, you get 96. Last question. A 1500 kilogram car start at rest and speed up to 3. The gain in kinetic energy is 6750. So when you start at rest, there's no kinetic energy, but when you gain, reach 3 meters per second, all you have to do is calculate your kinetic energy at 3 meters per second. So plug in your number for half mv squared, 1500 times half, times 3 squared, which is 9, you get 6750. So it is true. Alrighty. Oh, I guess we went back to the question I skipped. Okay, and here is your explanation. Just remember to study hard and go check your question and answer on the explanation video, and I'll see you next time.